Welcome back. In this series of lectures, we are playing with numbers. In the last class, we played with two-digit number. So what we saw there? If we saw there that if we have a two-digit number and if we interchange the digits of that number, and then if we add those two numbers or if we subtract one number from the another one, then what happens? Today we will play with three-digit number. First we will take a three-digit number, then we will interchange the digits, the position of the digits, then we will add them, then subtract them, and then we will see what happens or what we can do, how we can have the answer of addition or subtraction without performing the real addition and subtraction. So let's get started. Suppose we have a three-digit number, what we are representing here as A, B, C, where A is the digit at units place, B is the digit at tens place, and C is the digit at hundreds place. So how we can express this three-digit number in expanded form? C, it is at hundreds place, so it will be written as 100 multiplied by C. Then B we have at tens place, so it will be 10 multiplied by B, and then A we have at units place, so it will be 1 multiplied by A, and that means A only. Okay, fine. So we have three digits A, B, and C. So this way A to B, B to C, and then C to A. Now what we will do, we will change the positions of the digits in a cyclic order. So if we do that in anti-clockwise direction, then A will come here and B will go to the position of C, and then C will go to the position of A. Now the new number that will be formed from this interchanging of the digits is C. In place of A we have C, so we will write C at the units place. Then at the position of B now we have A, so at tens place we will write A. Then at the position of C we have B, that means at hundreds place we will write B. So this will be our new number. And how it will be expressed in expanded form? It will be 100 multiplied by B, then it will be 10 multiplied by A, then plus C. Now what we will do, again we will change the positions of the digits in cyclic order. So if we do that, then C will come here, so in place of A now we will have C. Now A was there, so A will now come at the position of B, so now we will have A here. And then in the previous step B was here, so B will now move to the position of C, so we will have B now here. So if we now take the sequence, then it will be B, C, and then A, and in that fashion we will be writing. So it will be B at units place in place of C, then we will have C at tens place in place of A, and then we will have A at hundreds place in place of B. And now if we express this three-digit number in expanded form, then it will be 100 multiplied by A plus 10 multiplied by C, and then plus B. Now suppose if we want to add these three-digit numbers, then it will be A, B, C. Then we will have the next number that we obtained after changing the digits of that number in cyclic order. Then we have B, C, and then A. So now if we write the expressions that we have, the expanded forms, all these three-digit numbers, then we will be getting this expression. Now if we club all the A's together, all the B's together, and all the C's together, then it will be 100A from the third part. Then in the second part we have 10A, so we will add with 100A, and then in the first part we have only single A, so we will be clubbing that, we will be adding with the other two A's. Then in the second bracket, in the second part, we will combine all the B's. Now we have 100B here in the second part, so it will be 100b, and similarly the way we had the expression of A, the similar kind of expression for B also will be getting. So here we have 10b, and then in the third part we have a single b, so we'll combine them. Then for the C also we will have the same expression as here we have 100c, so it will be 100c, then we have here 10c, so it will be 10c, and then in the second part we have a single c, so here we will be writing, or we'll be adding the c with other two. So if we add these three, then it will be 110 and then plus a, so 111a. Fine. Then from the second bracket also, from the second part, we will be getting 111b. Fine. Then from the third part, we will be getting 111c. That means in all these three parts of this addition, of this result of addition, we are having common factor 111. So it will be 111 then multiplied by, we will be having a plus b plus c. Now 111, if we factorize further, then 111 is 3 multiplied by 37. So it can be further written as 3 multiplied by 37 multiplied by a plus b plus c. So what we can conclude here, that if we have a 3-digit number, any number, and if we change the positions of the digits in a cyclic order in a fashion, then twice if we change them, and if we further change the position of these digits, then we will be returning to the first digit. That's why we have changed only twice. Okay, so now after forming these two new numbers, if we add all these three numbers, then finally in the result of addition we will be having these three factors. One of the factors will be 3, the other factor will be 37, and the third factor will be nothing but the summation of those individual digits. Now let's see what more we can conclude from this result of addition. So what we have obtained in the previous slide was, so these are the three factors that we will have in the result of addition of these three-digit numbers. Now suppose in this addition, this result of addition, if we subtract by 3, then what will be our result of division or quotient? Without really performing this addition and then further without really performing the division, we can answer, because we know in this type of addition we will be always having these three factors. So when this addition will be divided by 3, the answer or the quotient will be always 37 multiplied by a plus b plus c. Right. Now suppose if we have divisor like 37, when we will divide by 37, what will be the quotient? Again it will be 3 multiplied the other two factors, multiplication of the other two factors, so it will be 3 multiplied by a plus b plus c. Now suppose if we divide that result of addition by this factor a plus b plus c, then easily again we can answer that what will be the result of division or what will be the quotient, and this time it will be 3 multiplied by 37. Right, very easy. So we can play this way. Now suppose if we divide this by 1 1 1, then what will be the quotient? That is also easy, because we have already seen that this 3 multiplied by 37, this actually came from 1 1 1. This was the factor, and when we had in the previous line we had two factors, so one of the factors was 1 1 1 and the other factor was a plus b plus c, and when we refactorize this value 1 1 1, then we received or we obtained these two factors. So if one of the factor, or if we the result of addition, if we divide by 1 1 1, then also the answer will be, or the quotient will be a plus b plus c. So this can be further written as 1 1 1 then multiplied by a plus b plus c. Right. Now suppose if we take divisor like 3 multiplied by a plus b plus c, then what will be our quotient? The quotient will be 3, where we are dividing by 3 multiplied by a plus b plus c, so quotient will be the remaining factor that we have, and that is 37. Now next if we asked that if we divide this addition, this result of addition by this factor 37 multiplied by a plus b plus c, if this is our divisor, then what will be the quotient? So 37 multiplied by this, if we divide by this, then the remaining factor is what? 3. So the quotient will be 3. So this is the way how we can answer without really doing the addition or division. Now suppose if we want to perform this, where we have addition of three digit numbers and then we are multiplying that result of addition by 37, and if we want to really answer this without performing addition and division, then what will be the trick? The trick will be, now here what we can see that 1 2 3, this is a 3 digit number, so 1 2 and 3 this way. Now if we rotate, or if we change the position of the digits in a cyclic order, in anti-clockwise order if we go, then 1 will come here, 2 will go there, and 3 will go here. So the new number will be 312, and that's what we have here. And next if we change again the digits, so 1 will come here, then 2 will go there, and 3 will go here. So it will be 231. The third number will be 231 after changing the positions of the digits. So it will be 231. That means when we are adding these three numbers, basically there is a relationship between these three numbers, and that we have already seen what is the relationship. And now when we are multiplying by 37, how easily we can answer, because we have seen that when we add this type of three numbers, when there is because the other two numbers we get by changing the positions of the digits of the first number, then when we perform the addition, in the result of addition we will have these three factors, 3 multiplied by 37 and then multiplied by the three digits. So here it is 1 2 and 3, so 1 plus 2 plus 3. That means finally it will be 3 multiplied by 37, and then it will be 3 plus 2 5 plus 1 6. That means now further if we divide the result of addition by 37, then the answer will be what? The answer will be the rest two factors, that means 3 and then multiplied by 6. So it will be 3 6 18. So this is very easy. And if you know the trick that if there is a relationship between these three numbers, and if we divide by any of the factors, then easily we can answer that what could be the result of division after addition. And this we are doing without really performing the addition and division. Next we will take again a 3-digit number, and then we will interchange the digits of the first position and third position, and we will form a new number, a new 3-digit number. Then we will subtract one number from the other number, and then we will see what factors we will get in the result of subtraction. And then we will see how we can quickly we can perform that subtraction, and after that if we want to perform in division on the result of subtraction, then how easily we can answer. So here again we will take a 3-digit number, say A B C. So it will be further expressed as, and now what we will do, we will interchange the digits of the first position and third position. That means the new number will be A, B and C. So it can be further expressed as in expanded form like this. Now we will perform subtraction. Now when we will perform subtraction, we will have three scenarios. Three scenarios is, the first scenario or first case is when C will be greater than A. So if C is greater than A, that means CBA, this number will be greater than ABC, and then if we subtract this second number from the first number, then the result of subtraction will be positive, otherwise it will be negative. And this time we are focusing on the positive result. So when C is greater than A, we will be performing the subtraction this way. From CBA we will subtract ABC. So on the right side, what will be our expression? It will be 100C plus 10B then plus A. That is the expanded form of the first number CBA, and then from there we will be subtracting this expanded form. So it will have 100A plus 10B and then plus C. Now what we will do, we will separate all the A's, B's and C's. So if we do that, then from 100C we will subtract this C. Here we have minus, so it will be minus C. Next we will have 10B, and here again we have another 10B. So we in the second bracket, or in the second part, we will be having this subtraction, and then we have A and then minus 100A. So if we take minus common, then it will be 100A, and here it will be minus A. So minus minus, here basically minus 1. So minus A and minus 1, when we will multiply, it will give us plus A, and that is what we have within this first part. So now if we further simplify, then it will be 99C, then 10B and 10B will cancel each other, and then we will have minus 99A. So 99 is the common factor here, and then another factor is C minus A, and that is the result of subtraction between the digits that we have at first position and at third position. Now this is case 1. Now in case 2, or in the second scenario, what we will have, the scenario says that if A is greater than C. So if A is greater than C, that means A, B, C, this number will be greater than C, B, A. So now if we subtract, this is greater than, so from A, B, C we will be subtracting C, B, A, and if we do that, then what value we will be getting finally, or what factors is, first we will write the expanded form of this number A, B, C, and then we will write the expanded form of C, B, A. So it will be minus 100C plus 10B plus A, and now we will separate all the A's, B's and C's. So finally it will be 99A, B will cancel each other, minus 99C. So it will be 99, one of the factors will be 99 and the other factor will be A minus C. And in third case, in the third scenario, what will be the scenario when A is equal to C? When A is equal to C, that means ABC is equal to CBA, because A is equal to C. So if we perform this subtraction, then in place of, since A is equal to C, so in place of A if we write C, and in place of C if we write A, and B we are not changing, and B is in the middle position, the second position. So this will be our first number. This could be written this way, and the second number is again CBA. So this will give us finally 0. That means when A and C, both the values are same. Like if we have say 6, 7, 8, one number, and when we will interchange the positions of the first and second digit, so the new number is 8, 7, 6. And when the values of these two digits in the first position and the third position, when these values are same, like 8, 7, 8, so even if we interchange the positions of first digit and third digit, the new number will remain same, and that will be 8, 7, 8 only. And when we will subtract these two numbers, that will give us 0 only, and that's what is happening in case of in the third case. So these are the three cases that we will be getting when we will be subtracting one number from the other number. Now 99, if we further factorize, then it will be 3, then 33, then again 33 means 3, 11. So 99 will have three factors, 3, 3 and 11 if we exclude 1 and 99. So here the 99 in multiplied by C minus A further can be written as 3 multiplied by 3 multiplied by 11 and then multiplied by C minus A. Similarly, in the second case also it can be further written as 3 multiplied by 3 multiplied by 11 and then multiplied by A minus C. Next we will see how we can play with this subtraction and division. So here this is the result of subtraction. So we have two factors, 99 and C minus A. Now 99 further can be factorized as 9 multiplied by 11. So 99 will have two factors, 9 and 11, and 9 can be again factorized as 3 and 3. So 9 again have two factors, 3 and 3. So finally, or we can look at this way at the result of subtraction, that it has two factors, 99 c minus a, or we can say that it has three factors, 9, 11, and then c minus a, or we can say it has four factors, 3, 3, 11, and then c minus a. So the number we will be taking as this a, b, c, and then from there we will be subtracting a, c, b, a, and then on that result of subtraction, if we perform division, suppose if we want to divide this result of subtraction by 99, and without performing the division and subtraction, really if we want to answer, then easily how quickly we can answer, the quotient will be in this case c minus a, because we know the trick. Now if suppose we want to divide by c minus a, then the result of division will be 99, right? Now suppose if we want to divide by 9, that result of subtraction, then the quotient or the result of division will be 11 multiplied by c minus a. Now suppose if we want to divide by 11, then the result of division will be 9 multiplied by c minus a. Now suppose if we want to divide by 9 multiplied by c minus a, then the result of division will be 11. If we divide by 11 multiplied by c minus a, then the result of division will be 9. It's really interesting. Then if we divide by 3, then the result of division will be the multiplication of other factors. So it will be 3 multiplied by 11, then multiplied by c minus a. Now suppose if we want to divide by 3 multiplied by 11, then multiplied by c minus a, then the result of division will be 3, just the opposite of the previous one. Now suppose if we divide by 3 multiplied by c minus a, then the result of division will be the remaining two factors, which is 3 and 11. So the result will be 3 multiplied by 11, so it is 33. Now suppose if we do the opposite, means if we divide by 33 by this two factor, by the multiplication of these two factors, then the result of division or the quotient will be this time c multiplied by c minus a. So here we have all these combinations of divisors or divisions, and without putting much effort and time we can answer. Now next we will perform these two operations. So here what we can see is we have one 3-digit number 987 and another number is 789. So what is the relationship between these two numbers? When we interchange the digits of first position and third position, then we get the second number. And now if we want to subtract these two numbers and this result of subtraction, if we want to divide by 33, then quickly how we can answer is, we know in this type of subtraction, the result of subtraction has these four factors, 3, 3, 11 and c minus a. So it will have these four factors, 3, 3, 11 and c minus a. C and a mean the digits that we have at the first position and third position, and here we are writing c minus a, so the digit which is greater, that will represent here c. So it will be 9, and here a is the digit which is smaller, so it will be 7. That means in this example our factors will be 3, then 3, then 11 and then 2. So in the result of subtraction, if we factorize, then we will have these four factors. So the result of subtraction, now if we divide by 33, means 3 and 11. So what could be the result of division? The multiplication of other two factors, the remaining factors. Here the remaining factors are 3 and 2. So the answer will be 6. So if we know the trick, easily, quickly we can answer without even performing the subtraction and division. Now the next example is, here we are again performing this subtraction. So one number is 765 and the other number is 567. So how we are getting the second number? What is the relationship between these two numbers? We are interchanging the digits of first position and third position, then we are getting the second number. So we know again, when we will perform this subtraction, the the result of subtraction, we will have these four factors: 3, 3, 11. These three factors are fixed, they are constant, they will be always same, and the fourth factor is variable, and that is again c minus a. So here c will be the digit which is greater, that means 7, and always we will focus on the first position and third position, and the a will be the digit that we will have, that will be smaller. So here it will be 5. Basically c minus a or a minus c, how we represent this doesn't matter. Here always it will be the difference of the digits that we have at the first position and third position, and the difference will be always positive difference. So again we will have these four factors: 3, 3, 11, and then 2. Now if we divide this result of subtraction by 66, 66 means 6, 11. 6 multiplied by 11 means we will have 3, then 2. 3 multiplied by 2, 6, and then we will have the third factor, which is 11. So 3 multiplied by 2 multiplied by 11 is 66. That means what will be the result of division, or what will be the quotient? The remaining factor, which is 3. So if we know the trick, easily we can answer. So this is how we can play with 3-digit number. In the following classes, we will check the divisibility of a given number by other numbers like 2, 3, 4, 5, 6, 8, 9, etc. So till then, stay safe and stay healthy. Thank you.